every PCB. So this is a PCB designing is a different, sir. So PCB designing, there's an Altium, there is an Eagle, there is an KeyCAD or CAD
Yes, sir.
Proteus. There's a different softwares are there for PCB designing. So when the
Actually, which is the best software, sir? LT Space is also there.
okay,
Altium.
LT space actually for simulation, sir. Like
Okay.
whatever the circuit that we have made, what can be the expected output. That information will be given by the simulation.
Altium is okay.
Ultimate is fine. Ultimate would be yeah, it's really good. And Eagle also it's really good. And there's some softwares, but thing is that they are a little costlier.
Okay, sir.
So because free versions are not available in that. There's
Any
free
open source,
sources are
sir?
there. Free sources, KeyCAD was there.
Okay, sir.
KeyCAD or CAD. This type.
Okay, sir.
But it's again depends what type of software that you have to choose. And it is purely depends on the proficiency of your PCB. So you wanna do very perfect EMI EMC protected PCB, then you have to go for the higher version PCB design. So normal with boards like this you want to design is a KiCad is more sufficient. Okay. So here every PCB actually will have its own stencil for automotive assembly. Sorry, automatic machine assembly. Okay. So for example, if you consider this board, for this particular board there is any particular stencil. Sorry.
What does it mean, sir? Stencil in the sense?
Stencil, which is nothing but wherever the soldering to be happen, wherever the component just comes and plays on the PCB, that particular place will be opened. Okay. Wherever the metal contact to be placed, that particular place will be opened. That we technically will call it as an aperture.
Yes, aperture.
Yes.
Okay.
So there is any reference points here, reference 1 and reference 2.
Okay.
So these are the reference actually which defines the coordinates here. Like this is the 0 coordinate. So every component in the x direction and y direction. So with reference to this is the 0 0. So from 0 0 how much distance the component was placed. This all information will be given by the PCB designing software. So those information is needed to feed in this machines to do the process. Okay. So here if you have observed there is a reference 1 and reference 2. Similarly in the back side you can observe the reference 1 and reference 2.
Okay, the same arrangement.
Yeah.
But the
So
size of the
this
board
machine-
differs, no, sir?
Sir?
Size of the board.
Huh.
If we take like this board means the dimension is completely different, no?
No, that's what I am telling. For every PCB, the stencil will be different.
Oh, okay,
For this board, the stencil will be this one. Okay. So actually, these things, particularly for 1 or 2 PCBs, it will not be helpful because it is very costly. Okay. But you are doing a thousands of quantity, so this process will be suggested.
Okay, you can create the according to that dimension.
Yes, sir. Actually, this thing, the Gerber file, whatever which is generated by the PCB designing software, so the same Gerber file used for the PCB designing as well as for the stencil design.
Okay, sir.
Okay. So this is the thing. Actually, this mission it is in a solder-based printing mission, so which consists of a camera assessing system to align these fiducials and the stencil fiducials. So it will be assigned properly.
Okay.
So after that there is any so this is the stencil that we are just keeping in this thing, right? So this will be kept like this. Under this there is a conveyor automatically, so we have to teach these fiducial points through this system. So automatically this will get aligned to the stencil and the solder paste. Tambi paste comes here. So this will call it as any solder paste. So normally we seen, right, any soldering that we are doing, there is any solder wire will be there. So we will apply some temperature that will get melted and it will make any mechanical bonding between the component and PCB substrate. So the whatever you are saying, it is any solid wire solder.
Yes.
But this is any semi-solid. Okay, it's a liquid. Okay, so this thing actually we will place it here and this is the squeegee we will call. So this squeegee it will wipe the solder paste from front to back and bend back to front.
Okay, sir.
The paste will be exactly deposited on the
First, initially it is completely deposited over the pad.
deposited.
Okay.
Yeah. So this solder paste is consists of different metal compositions. One is a tin, silver, and copper. So there is a certain percentages are there. Depends on the part number of this solder paste. If you have seen, this is any SAC 305 solder paste.
Here also.
Yeah. So SAC 305, the 3 which indicates about the silver, and 0.5 305, right? So 3 which indicates about the silver content, and 05 is 0.5% of copper.
Copper content.
Okay.
It's a combination of the liquid. Is a combination of all these.
Copper and tin. So tin will be same for the different type of solder paste. For example, consider I am taking SAC 305. I can take SAC 307, 309.
Okay.
Like that. Okay.
Yes, sir.
But in this all contents, the tin percentage is always same. 96.5% always tin will be same.
In what way we consider the copper, sir? For single layer, multi layer, it differs in that way,
it's
sir.
not like that. It's like a pure conductivity. It's like, for example, consider you are using a very high frequency related PCB and which consumes very less power. In certain applications, the resistivity of the solder paste to be very less. Okay, so in that condition you will select it. And also the component manufacturer itself, in the data sheet they will mention which solder paste is suitable for their component. So we will follow in that way.
Oh, they will give the
They
request
will
along with the
recommend- they
Gerber
will
file.
recommend, sir. They will recommend.
Okay, sir.
So the solder paste selection, actually in this solder paste there is 7 types of solder paste are there.
Oh.
Type 1, type 2, type 3, type 4. So it is like whatever the metal composition that we have discussed, like tin, silver, copper, which is actually like a solder balls. Okay, so each solder particle it is having a different size. Okay, so if it is maintained a 10 micrometers of diameter of the solder particle, so there's a different type. And if it's having 20 micron, 30 micron, and 40 micron, the type will be changed. So the type actually which will define is the fine pitch component, for which fine pitch component the solder is to be used. Okay, so in the component data sheet they will mention SAC 305 type 1 or type